Hello. Welcome back to the channel. So let's move on to a new topic, which is about series. So before moving on to series, we have already covered all the concepts regarding sequences. So I'll highly suggest you to first watch all the videos about sequences in order to get the full idea about what a series is and also to get a good idea about what type of questions we will be getting in series, which will be solved using all the concepts in sequences. So now the first question is, what is a series? A series is basically a sum of sequences. So if you take a sequence and add all the terms in the sequence, you'll get a series. So a series is a sum of infinitely many terms, and in the summation notation it is written by this summation over here, summation n equals 1 to infinity of a of n, where you know that a of n is basically your sequence, right? So you took a sequence and you added all the terms in the sequence until infinity to get a series. So now let's use all the concepts of sequences that we covered in the last videos and the series definition in order to solve this question over here. So we have been given that we have a series whose sum of n terms is given by this formula over here, and based on this sum notation we have to calculate a of n. That means we have to calculate the sequence, we have to calculate the limit of the sequence, which is limit n tends to infinity for a of n, and we also have to evaluate what this sum would be if we take s of infinity in this case, right? So now in order to calculate e of n, we know one thing, that since our s of n is basically sigma n equals 1 to capital N for a of n, we can expand s of n as simply a1, a2, a3, a4, so on until a of n in this case, right? And now we have to calculate a of n. So in order to do that, if we take s of n minus 1, we are basically adding a1, a2, a3, a4, so on until a of n minus 1, right? And in this case, if we expand this as well, we are basically adding a of n minus 1 plus a of n in this case, right? And now you can notice that if we subtract s of n minus 1 from s of n, we'll cancel all these terms over here except the a of n term. So now we have a relation that s of n minus s of n minus 1 is equal to your nth term in the sequence. So we can use this formula in order to calculate our sequence. And let's do that. We know that our s of n is basically n upon n plus 1. So this would be, our a of n would be n over n plus 1 minus n minus 1 over n minus 1 plus 1, right? In order to calculate s of n minus 1, we just substituted n minus 1 instead of n, right? And if we solve that, we will get a of n equals n upon n plus 1 minus n minus 1 upon n in this case, right? And this will be simply n square minus n minus 1 times n plus 1 over n times n plus 1. So you'll get your a of n as n square minus, this term would be a minus b times a plus b will be a square minus b square. So this would be a square minus b square upon n times n plus 1. Finally, your an would be 1 upon n times n plus 1 in this case, right? So your sequence would be represented by 1 over n times n plus 1. And we calculated our sequence by only using the summation notation for our s of n, by using the expression which we were given for s of n, right? And now we have to calculate the limit of the sequence. The limit of the sequence is simply limit n approaches to infinity of a of n. In this case, we know our a of n, so limit n approaches to infinity, 1 over n times n plus 1. In this case, since our sequence is in terms of capital N, so we'll change the limit in terms of capital N as well. So this is capital N approaches infinity on both sides. And you know that if we take limit n approaches to infinity for this expression over here, our denominator goes to infinity. If our denominator goes to infinity, our limit will simply be equal to 0 in this case, right? So now we have calculated a of n. We have also calculated the limit of the sequence of a of n. The only thing which is remaining is to calculate the sum when your terms are infinite. So sum of the series in this case. And you know that since we already have a notation for our sum, if we take limit for capital N approaches to infinity of our s of n, we'll simply get s of infinity in this case, right? And that is what we have to calculate. So we know that capital S of n is basically n upon n plus 1. And now we want to calculate s of infinity. So s of infinity is basically limit capital N approaches to infinity for our s of n. And this would be simply limit capital N approaches to infinity n over n plus 1. And we know that if we take n common in the numerator and in the denominator, we'll simply get limit capital N approaches to infinity 1 over 1 plus 1 by n. We have taken n common in the numerator and in the denominator. So now you can clearly see that if you take limit capital N approaches to infinity, for this expression over here, this approaches to 0. So your sum of the series, your S infinity, when you will have infinitely many terms in your series, in your sum expression, your sum will be equal to 1 in this case. So as your terms approach infinity, your S of infinity, your sum for the series will be equal to 1 in this case. So that's it for this video. In this video, we covered the basic concepts of series and used all those concepts in order to calculate sequences and also calculating the sum of the series when you have infinitely many terms and have been given a notation for your sum. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.